Introduction to exponential functions. I'm Anil Kumar, and now let us understand exponential functions. The question here is, explain how you know that the graph of the function given below is that of an exponential function. Write 5 characteristics of this function. So that is a graph which is given to us. It looks like an exponential function, always increasing, right? Domain is all real numbers and range is greater than 0. Now the question here is, how do you justify that this is an exponential function? Now best way to justify is to find the first difference. Okay, so what we will do is we'll take up some points and find first difference. Let's take up some points first. So I'll write down x and y values and then calculate the first difference. If the first difference is a multiple, right, or it has a multiplication pattern, then the function is exponential, correct? So that is the best way of figuring it out. So let's take these points. At 0, this value is 1. At 1, the value seems to be at 2. At 2, it is 4. At 3, it is 8. And at 4, it is 16. So these are good points to take. So at x equals to 0, we have y as 1. At x equals to 1, y value is 2. At x equals to 2, y value is 4. At 3, y value is 8. At 4, it is 16. So these are the points from the graph itself. And now let us find first difference, right? So let us find first difference. First difference is, for every change in x value, a unit change in x value, by how much does y changes? That means y2 minus y1, right? So we'll do 2 minus 1, 4 minus 2, 8 minus 4, 6 minus 8, right? 2 minus 1 is 1, 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8. So clearly what we notice here is that first difference has a pattern, right? So what we find is that the first difference is 1, 2, 4, 8, right? So like this. So it is times 2. So it's a multiplication pattern, and that justifies that the data or the graph represents an exponential function. So therefore, we have exponential function, right? And if you can notice, we could write y equals to 2. 2 is the multiple, so that gives you an idea about the base. And 2 to the power of x is the equation of this function from the graph, right? 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4. Likewise, you could also check at 2 to the power of minus 1, we are going to get half. 2 to the power of 2 minus will be 1 over 4. Difficult to read, right? But that's the pattern which you notice, right? So the best way to answer this is to find the first difference and then say that this first difference is following a multiplication pattern, and that means it's an exponential function, right? So that is basically a multiplication pattern. Right, so that is how we justify. And now let us write down 5 characteristics of this function, right? So best characteristics are domain, range, intercepts, right? So these are good characteristics to begin with. So first is, we know domain is all real numbers. Right. As far as the range is concerned, we can say range is, let's say range is y values. We could write in curly brackets that y is greater than 0 where y belongs to real numbers, correct? So y values are greater than 0. Then horizontal asymptote is a very good is characteristic of exponential function. So horizontal asymptote in this case is the x-axis, which is y equals to 0. We can talk about the y-intercept. So y-intercept is at 1, right? At y equals to 1. So anything to the power of 0 will be 1. That means x equals to 0, 2 to the power of 0 will be 1, right? So y-intercept, and then we can say that the function is always increasing. So if I draw a tangent at any point, we'll get it with positive slope, starting from almost 0 to infinitely large value, right? So these are good characteristics to talk about when we are discussing exponential functions. I hope that helps. Thank you and all the best.